cakep.
Pergi boleh sekarang. Mana ni?
So, let me demonstrate how this turbine works. So, the water comes from the top, it goes to the bottom. And gravity pulls the water down, also known as acceleration due to gravity. So as gravity is pulling that water down, as it is forced, the velocity is rising. So the water comes in, the water comes in here, it enters through the back, not a break there. So the water enters right here, and then it moves like this. So the force of water is hitting the blade, and it is turning like this. So this is the turbine itself. This is the turbine. This is the shaft, which is transferring the motion to the pulley. These are the bearings. These are the same bearings which I use on the milling machine. These are just mild steel metals which I made. But as we all know, mild steel lasts when you put it into, when you expose it to the moisture. Mild steel lasts when it is exposed to moisture. So when building an actual turbine, like this is just a prototype. But when building the actual one, we don't have to excuse me. When building the actual one, we cannot use this mild steel metals or other material to do turbine because they last when we expose them to moisture or water. So the materials that we can use are stainless steel, which are resistant to moisture, or aluminum. Those are the materials that can be used, and galvanized steel. Yes, that is the materials which can be used. But for the prototype, it is okay. It is okay to use mild steel. That's why I use it, because it is cheaper. I didn't have that much to make a standard turbine, so I just used what I was able to afford. So that's why I use these cheap metals or other materials. So according to my budget, that's why I went for mild steel, because mild steel is cheaper, and the wires for mild steel or other electrodes used for welding mild steel is around 1 kwacha, or in other hardware 1 kwacha 50 weight. But the wires for mild steel are around 15 kwacha, so that's why I use mild steel. Although it lasts, but it is durable, but it lasts. So it is not recommended to use mild steel in water, but that's what I was able to afford. So these are the bearings. I got them from the milling machine. These are all mild steel. This is a belt, the same belt which is used on a milling machine. So the pulley there, I got it from a bicycle, a small bicycle. I got all the spokes and then modified it and built my own thing. So that pulley there, which I got from a bicycle wheel, is transferring the mechanical energy from the turbine and turning it into motion. So the pulley, come here closer. So the pulley is transferring that motion to this small generator. This small generator produces 3-phase alternating current. So that 3-phase is not usable when I want to use it directly. Because, okay, it can be used if I connect a transformer, but the bulb will be doing like, it switches on, turns off, like it will be dim and then bright. So the only way I solved that is by converting that alternating current into direct current. Because direct current can, I can make it to be smooth. Like direct current, the waves, the power, I can make it to be smooth. So by using capacitors, so I created this device which is converting that alternating current into direct current, which is right here. So this is a full wave 3-phase bridge rectifier. I made it myself because I went around in the hardwares in town. I couldn't find it. So I just decided to do my own research on the internet, and then I developed it. I made it myself. This is a full wave 3-phase bridge rectifier, which is used to convert alternating current into direct current. So these are 6 diodes, they are called diodes. These are 6 diodes which are converting 3-phase alternating current into DC direct current, which only uses 2 cables, a positive and a negative. So this is a positive and this is a negative. Positive, negative. This is a 3-phase full wave bridge rectifier. I tried to buy it on eBay, but it was quite too expensive. It was around $50. Imagine how much is that in our Zambian currency I'd like now. So I just decided to make my own thing. I mean, the working concept is the same as the one they were selling on eBay. So I decided to make my own since I was unable to find one in the hardware. So they converted DC, and then I added the capacitor. This capacitor here, it helps to smooth out the power, which would rather be, how can I put it? It helps us to smooth out the wave. When those who were in school, like according to physics, the wave it goes like this, the 3-phase wave. But for alternating current, it goes like this. But for direct current, it's just a straight line. So sometimes it will make a bump. So I added the capacitor to smooth out those bumps. That's the simplest explanation I can put it. So the converted and smoothened direct current, or rather DC, is then transported through this cable right here. So this cable goes into the water, but it is not harmful. It cannot kill someone, because that's the good part of converting it into direct current, because direct current cannot kill someone. So direct current can't kill someone. So don't feel that why have you put the cable in the water. That's why I converted into direct current, to smooth out the power and to prevent anyone from being harmed or rather to kill someone. So that's why I converted, because direct current is safer than alternating current. So the cable passes through the water. The cable, it goes up there. That is the cable to the inverter. So let me just show you where it has gone. There to the inverter. So let me try to connect this speaker here and see if it will turn on. So the speaker here has been turned on, as you can see. So here's the connection. It goes down. This is the cable. It goes down. As you can see, there is nothing like a battery. It's just this cable, which is connected to the small generator there. That is a 3-phase generator.